Ladies and gentlemen, my name's Paul, and in this Game.com video we're going to be discussing the machine, which is built by HP. Now, the machine is a high-end supercomputer which is revolutionary in many design philosophies. Now, you might think that that's actually me overselling it a bit, and it's really not. The design of the machine, and yes, I have to keep calling it that because it reminds me of one of my favourite TV shows, Person of Interest, and it is definitely worth watching that, by the way. It's a shame it ended, but there we go. The machine is 8,000 times faster than a traditional system, and it does this in a number of ways. It uses photonics to transfer information via light, and the computer itself has a very different philosophy when it comes to the memory side of things. Now, let's go a little bit into detail on how all of this works. Regular viewers of RGT will know that I've often used the term the convoy sails as fast as the slowest ship. In other words, if you have a bottleneck in a design, for example, a very simple example would be if you have a high-end CPU, let's, for the sake of argument, say the i7-6700K, but you were to bottle that against the almighty power of, let's say, a GTX 760, and then you were to try and play a new game, let's say Doom, at 1440p, it doesn't particularly take me to tell you that, yeah, you're going to have some issues running at high resolution with all the details at max. And also it doesn't take me to tell you that the CPU is going to be the issue. And thus is the challenge with supercomputing. You can't just take an existing component, tweak it, but leave all of the other components as is and think that there's not going to be an issue, because obviously even if you have a very fast CPU, you might have issues getting the amount of data into that CPU from memory, or it could be that the storage pool, for example the hard disks or SSDs, could be the slow part of the convoy. So what HP did here is they essentially redesigned almost all of the computer from the ground up. At its simplest level, the machine, just like most processors, just like most computers, is processors accessing a memory pool. But the difference here is the machine does so by a bunch of processors accessing a universal memory tool, once again using photonics, in other words light. Now, this means that they are most likely using heterogeneous specialized cores or nodes, and obviously the photonic-based CPUs to the universal memory pools can access very quickly. Another very interesting point is that the memory itself, from what we can tell, is non-volatile. Combine all of this with a new operating system, so no, we're probably not going to be seeing a version of Windows Server on this at any time soon, and you have the basic chemicals of how this works. It's also rather interesting that the processor itself doesn't necessarily have to adhere to a specific architecture or instruction set. So for the sake of argument, you don't necessarily need to go the x86/64 route. You could also mix it up with, let's say, ARM. And this means you can go either single socket or multi-socket. The machine's processor at its heart is really a SoC. Folks who have been following, let's say, the PlayStation 4 or any other console development for a while will know basically what a system on a chip is. In this case, it combines multiple different parts, including, and perhaps the most important part for this machine, the photonic interconnect. So all the photonic really does is both the means of the silicon and the other piece of silicon, so for example the CPU talking to a piece of memory, communicating with one another, and it does this via light. So basically light can travel much faster than, let's say, an electron flowing down a piece of wire, or in the case of a circuit board, a traditional trace. Now I do realise that this is not really something we cover a lot on RGT, so I do wonder if you guys are interested in this, and if so, definitely let us know and we can do a lot more of these type of videos. The prototype itself is, well, only a prototype, but even so they've managed to squeeze 8 terabytes, I'm going to repeat that word, terabytes of memory into it. That is absolutely astronomical. I mean, That's a lot of memory. So the machine itself at the moment is just a prototype, but the keyword is it's a working prototype. And eventually they will be, of course, rolling this out to their usual partners. Now, this stuff, for the very super duper high end, is probably going to mostly focus on the traditional servers. It's going to be for HPC, high performance computing. So for the sake of argument, Facebook, the Googles are going to be wanting it, or perhaps scientists if they're trying to map DNA, or perhaps understand the gravity effects of a star in a particular constellation or a galaxy, and start doing some serious calculations for perhaps tidal movements of certain bodies. But with all of that said, the technology in theory can be downsized to different devices. Now, I'm not here to tell you, I'm not here to sell you this, because at the end of the day, I'm not being sponsored or anything like that by HP, and I'm certainly not someone who's going to claim that the future is here, because ultimately there have been a lot of theoretical futures. Just for the sake of argument, go back to 1990 and look at some of the technology. A lot of folks would have sworn blind that FMV was going to be pretty standard in gaming for a long ass time. Do you remember when the Sega CD and Philips CDI and all of these consoles were really pushing video? Now, I'm not saying that the Sega CD or any of these consoles were bad, but in my opinion, there were a couple of cool games on the Sega CD, for example, that were FMV based. For example, Dragon's Lair and Road Avenger. I forgot what it's called in the States, but in Europe it's called Road Avenger. But most of the titles that were really good on Sega CD weren't necessarily FMV based. So you had, of course, Sonic CD or whatever. My point being that a lot of the time, future isn't not necessarily how we expect it to be, but this is certainly one possible technology in the future. And considering that we are definitely running at the mercy of Moore's Law, you know, Moore's Law is chasing us with a machine gun at this point, and we're like hiding behind cover quite often, and naturally we're shrinking down the NM, so to speak. You know, we've gone from God knows what down to 28, and now it's shrunk to 20, and then it went to like 16 or 14 depending. Naturally some is also going to 10, and we're probably going to start seeing that squeeze into the regular desktops over the next few years. But really it is just putting off the inevitable, and once you start getting to single digits, let's say 5nm or whatever, it gets really hard to actually fight this. And this is one of the reasons that Intel themselves are no longer using the traditional tick-tock. That's why they're using architecture optimize and process, which is pretty obvious. Architecture would be a new architecture. Optimize is you're taking that particular architecture and you're tweaking it to improve it, and then obviously you're shrinking down the node. And basically they believe that's much better in terms of how the Candice works now. It's a lot harder to actually squeeze in the traditional large performance gains. Like, look at the days of the Pentiums, like the early Pentiums, Pentium 1 to Pentium 2 to Pentium 3 to Pentium 4. And yes, the difference between, let's say, the Pentium 1, there were multiple Pentium 1 processors. There was like the original Pentium 1, there was the Pentium Pro, there was the Pentium MMX, and the Pentium 2 and the Pentium Pro were very close to one another architecturally, but what they did do, of course, is they made some other changes which definitely spiked up the performance of the, or rather the clock speed of the chip. My point being that there are always people pushing the envelope, and I wish HP luck in this. I think it's going to be really cool. Now, getting back to the actual focus of the video, rather than me spouting and waffling on, HP are planning, as I mentioned, to release this formally, commercially, and most likely it's going to hit in 2018 to 2019, so let's be honest, it's going to be 2019, because things always run behind schedule, which is absolutely fine. I don't have any issue with that, and it's going to be very cool technology, at least in my opinion. And considering that when a traditional computer, that would be whether it's a desktop or all the way down to your smartphone. Like if you've got an iPhone or bloody, you know, the latest LG or whatever you're running, calculations are often slowed down because of not just the processor speed, but also the transferal of data between different processors over different buses. So, just once again as an example, it can be the CPU taking or sending data to another CPU, or cache to another CPU, or the main DRAM to a particular CPU, or the CPU sending instructions to the GPU and the GPU farming out those instructions back to the main system memory, and it's paging back and forth. So yes, fast processors are definitely very important, but also fast memory pools as well. And this is going to be very cool. And the fact that it can actually access all these memory pools simultaneously is going to be very impressive. But anyway, hopefully you've enjoyed the video. Let me know if you're interested in this type of stuff. I was going to go kind of in depth into it, more deep, but I'm not really sure if folks are like really interested in this type of thing. So let me know. You know, if you are, then I can definitely start making more videos like this and putting more analysis behind them. But I guess this one's just more testing the water, don't you know. Anyway, hopefully you've enjoyed the video. I'll see you all soon. Normal thing, if you can like, share, comment and all of that crap, since YouTube is being very unhelpful at the moment with its helpful algorithms. I'm sorry, I mean, you know, not that Google do anything wrong, don't you know. I'm going to get going. I'm really hyper tonight. I think it's just mostly that I'm extremely tired, and for some reason that activates the hyper bug. I have no idea how that works. Anyway, hopefully you've enjoyed the video. I'll see you soon. Take care. Bye for now. And thank you, phone. That was not at all inconvenient. Why couldn't you have beeped like 5 seconds later? Anyway, bye for now.